Okay, so let's talk about an example where it's not necessarily a ranking of like first, second, or third, but a specific place. So I don't think all of you have Mr. Earl, but I know a lot of you are a big fan of his Amor Shandy videos, which I also am a big fan of. He has 7 different pieces of floppy disk art. And for the sake of this problem, we're going to assume that they're all the same size, that he hangs on the wall in the background of his videos. So he's trying to figure out the best way to arrange his art. He has picked 7 different spots on the wall to hang these different pieces of art. How many different ways can he arrange it? Well, if he's got 7 spots that are like boxed out on his wall behind him, and you need to figure out which ones go where, you're going to take one piece of art and put it in one spot, which means you have 6 spots remaining and 6 pieces of art. And then he'll take another one and put it in a different spot, of which then he has 5 spots with 5 pieces of art remaining. So we're talking about a specific placement. So the order of where you put it matters. And then nothing repeats. You can't put the same piece of art in 2 different places, which means that this has to be a permutation calculation. Now, your n is the total number of objects that you have. So that's 7. And then permutation, he has 7 spots. Now, maybe he ordered like 13 pieces of floppy disk art and he only has spots for 7. So that would be 13 permutation 7, right? But here he has enough spots for all of the pieces of art. So it's 7 permutation 7, which, if you think about it, is just 7 factorial. Factorial is also on your calculator because factorial, if you were doing like 120 factorial, you don't want to do 120 times 119 times 118 times 117 times all the way down to 1. So it is in your probability. Hopefully you saw it before you went to permutations. It's number 1. So you go to menu, 5, and then 1 is factorial. So I'm going to do 7, menu, 5, 1 factorial, which is, he has 5,040 different ways that he could arrange just those 7 pieces of art on his wall in specific spots. Okay. At the end of the year, I would like to hand out superlatives to the Math 9 Accelerated class, the silliest mathematician, the most outgoing mathematician, and the quietest mathematician. Out of the 24 total Math 9 Accelerated students, how many different ways can I choose these superlatives? Now, we're picking 3 people out of the total of 24. So our total number of objects or people we can choose from is 24, but the number of slots that we have are 3. Again, this is not necessarily a ranking of first, second, or third, but they are specific spots that you have to put people in. I'm not going to just choose 3 people and say, hey, you 3 won these superlatives, but I'm not going to tell you which one, right? It could be the silliest one or the quietest one. That's a big range of difference. So we're not talking about a specific order, but a specific spot that they go in. So here, the number of options is 24. And then the number of slots is 3. So that's going to be 24 factorial over 21 factorial, 24 minus 3. Or we can go menu 5, 2, and do 24, 3. And that is 12,144 different ways I could assign those 3 superlatives. After the series finale of Game of Thrones, Mr. Williams and Mr. Margerison got in a heated debate about which episodes were the worst out of the total of 67. They decided to rank all episodes from best to worst. How many different ways can you do this? So this is a very obvious ranking: first, second, third, fourth, and so on. So if we're talking about 67 episodes and 67 options, it's going to be 67 permutation 67, which is really just 67 factorial. Menu 5. Oh, nope. Menu 5, 1. You will get a number that has E94 at the end. So remember that that is scientific notation in disguise. Oh, not 67. 94. I'm going to do the squiggly lines because I didn't use all of the digits. So it's about 3.65 times 10 to the 94. That's 94 zeros. So 94 divided by 3, because 3 zeros signify like million, billion, trillion, quadrillion. So that's a lot. I don't even know. I'm sure we have a number or a name for a number that is that large. But there's a lot of different ways that we could rank these episodes. Okay, so that's what permutations are all about. It's about having no repeats, right? So you can't have the same person be in multiple superlatives. You can't use the same piece of art in 2 different places. And there's a specific place in which you have to put that person or object. So that it's this idea of order matters. Okay, so that is permutations. You have all of the information you need to know in order to get started on your homework.